Hello students, let's continue the new topics of surface chemistry, and topic is factors which affect the extent of absorption on solid surface. Porous and finally powdered solid, as for example charcoal and fuller's earth, absorb more as compared to the hard non-porous materials. Due to this property, powdered charcoal is used in gas masks used in coal mines. Gases with high critical temperature are absorbed at higher extent as compared to gases with lower critical temperature. Second factors, a surface area of the solid absorbent. The extent of absorption depends directly upon the surface area of the absorbent. Means larger the surface area of the absorption, greater is the extent of absorption. Third factor, effect of pressure on the absorbed gas. An increase in the pressure of the absorbed gas increases the extent of absorption. At low temperature, the extent of absorption increases rapidly with pressure. At low pressure, the extent of absorption is found to be directly proportional to the pressure. And at high pressure, close to the substitutes vapor pressure of the gas, the absorption tends to achieve limiting value. Now, new topic, French absorption isotherm. French absorption isotherm is obeyed by absorption where the absorbate forms a monomolecular layer on the surface of the absorbent. According to French isotherm, X upon M is equal to K P raised to 1 upon N, and this means log of Xn, X upon M is equal to log K plus 1 upon N log P. Here, X is the weight of the gas absorbed by m gram of the absorbent of gas at pressure P, and X upon M represents the amount of the gas absorbed by the absorbent per gram. K and N are constant at a particular temperature and for a particular absorbent and absorbate. N is always greater than 1, indicating that the amount of the gas absorbed does not increase as rapidly as the pressure. At low pressure, the extent of absorption varies linearly with pressure. X upon M varies P dash, and at high pressure it becomes independent of pressure. X upon M where is P0. At molecular pressure or at moderate pressure, x upon m depends upon the pressure raised to powers x upon m, where is P raised to 1 upon n. Now, absorption isotherm, a mathematical equation which describes the relationship between pressure P of the gaseous adsorbate and the extent of absorption at any fixed temperature is called absorption isotherm. Here, x gram of an adsorbate is absorbed on the m gram of the adsorbent, then extent of absorption is equal to x upon m. Now, in Friedrich absorption isotherm, this graph indicates physical absorption and this graph indicates chemical absorption. The physical absorption isobar shows a decrease in x upon m throughout with rise in temperature, and chemisorption isobar shows an initial increase with temperature and then the expected decrease. The initial increase is because of the fact that the heat supplied acts as activation energy required in chemisorption like chemical reaction. Now, adsorption from solution. Solid surface can absorb solutes from solution. A few examples: when litmus solution is shaken with charcoal, it becomes colorless because the dye of the litmus solution is absorbed by charcoal. When the colorless MgOH2 magnesium hydroxide is precipitated in the presence of magnesium reagent, blue colored dye, it acquires blue color because the dye is absorbed on the solid precipitate. The extent of adsorption from solution depends upon the concentration of the solute in the solution and can be expressed by the Freundlich isotherm, and the Freundlich isotherm for the adsorption from solution is x upon m is equal to k, here c raised to 1 upon n, where x is the mass of the solute absorbed, m is the mass of the solid adsorbent, and c is the equilibrium concentration of the solute in the solution, and n is constant having value greater than 1, and k is the proportionality constant. The value of k depends upon the nature of solid, its particle size, temperature, and the nature of solute and solvent. The plot of x upon m against c is similar to that Freundlich adsorption isotherm. The above equation x upon m is equal to kc in spite of p raised to 1 upon n may be written as log x upon m is equal to log k plus 1 upon n log c. C is the equilibrium concentration of the solute in the solution. Now, factors affecting absorption from solution. The absorption from solution by solid absorbent is found to depend upon the following factors. Number 1, nature of the absorbent and the absorbent. Second, the absorption decreases with temperature. Third, greater the surface area of the absorbent, greater is the absorption. And fourth, concentration of the solute in the solution. Now, new topic is positive and negative absorption. In case of absorption by solid from the solution, mostly the solute is absorbed on the surface of the solid absorbent, so that concentration of solute on the solid absorbent on the surface of the absorbent is greater than in the bulk. However, in some cases, the solvent from the solution may be absorbed by the absorbent, so that the concentration of the solution increases as compared to initial concentration. Now, this is important that when the concentration of the absorbent is more on the surface of the absorbent than in the bulk, it is called positive absorption. And if the concentration of the absorbent increases in the bulk after absorption, it is called negative absorption. Bulk solution plus concentration KCl solution, this is positive absorption. And bulk solution plus dilute KCl solution, this is negative absorption. Now, applications of absorption. The phenomenon of absorption finds a number of applications. Important applications are: number 1, production of high vacuum. A bulk of charcoal cooled in liquid air is connected to a vessel which has already been exhausted as far as possible by a vacuum pump. The remaining traces of air are absorbed by the charcoal to produce a very high vacuum. Now, second application in gas mask. It is a device which consists of activated charcoal or a mixture absorbents. This apparatus is used to absorb poisonous gas, as for example Cl2 gas, carbon monoxide CO, and oxide of sulfur, and etc., and thus purify the air for breathing is coal mine. Now, third application for desiccation of dehumidification. Dehumidification. Certain substances have a strong tendency to absorb water, such as silica and aluminum. Al2O3. These substances can be used to reduce or remove water vapors or moisture presence in the air. Silica gel is also used to dehumidification in electronic equipment. Removal of coloring matter from solution. This is fourth application. Animal charcoal removes colors of solutions by absorbing colored impurities. It is also used as decolorize in the manufacture of cane sugar. And fifth application, heterogeneous catalysis. Mostly heterogeneous catalytic reactions proceed through the absorption of gaseous reactants on the solid catalyst. For example, finally powdered nickel is used for the hydrogenation of oils. And finally, divided vanadium pentoxide means V2O5 is used in contact process for the manufacture of sulfuric acid. And platinum means PT and PD are used in many industrial processes as catalyst. And manufacture of ammonia using iron as a catalyst. Now, sixth application, separation of inert gases. Due to the difference in degree of absorption of gases by charcoal, a mixture of inert gas can be separated by absorption on coconut charcoal at different low temperature. Seventh application, softening of hard water. The hard water is made to pass through a column packed with zeolite, sodium aluminum silicate. And eighth application, deionization of water. For softening, water can be deionized by removing all dissolved salts with the help of cations and anions exchanger resin.